And we're live. Take it away.
Hello, everybody. I'm so delighted to welcome you to the inaugural CETI Enchanted Tech Festival, focused on wearables and costumes. As part of this festival, we've had this amazing series of workshops and speakers, and today is the last of our amazing talks, but they're all on YouTube. They're going to be there. We'll edit and caption the videos and put them back on. So follow them if you can and share them with other people. These have been incredibly inspiring. To learn more about CETI, so I'm Nandini. I'm the founder, along with many other people, of CETI, a creative and emergent technology institute. To learn more about us, find us on our website, ceti.institute. Our social media is the same. Sign up for our newsletter on the website. And today, I am. Before I get to the inspiring part, I wanted to mention that this amazing series of sort of impromptu summer festival is possible because of the generous support of the Oregon Community Foundation and of Portland State University, which has given us this beautiful lab space. And come and find us eventually once the world opens up and it's safe to do so. And this, as we go through the talk, I will, after introducing everybody, sort of wander off and lurk in the background. Post your questions on the YouTube chat. The amazing Helen Lee, who is this incredible artist, musician, technologist, just does magical things, runs streams, moderates just inspiring conversations, is going to lead and moderate this. She will ask your questions and some others. Helen also did some of our incredible workshops that are on the YouTube site, so you should watch those, and has been sort of the energy behind this whole festival. So thank you, Helen. Also, we'll be following up with more conversation on our Discord, so send email to hello@ceti.institute if you want to join that conversation and join the community on the Discord. But now, it is my just great pleasure in introducing Dr. Kitty Yeung, who's joining us all the way from Berlin. This is going to be, you've seen a variety of different kinds of talks, and this is going to be another amazing one. Kitty is the Senior Program Manager at Microsoft Quantum Systems. She produces a tremendous amount of Microsoft learning modules around quantum learning, but she is also an incredibly, she has a unique and brilliant set of talents and expertise. She's a researcher in quantum computing. She works in fashion and has an incredible brand called Art by Physicist that you're going to hear more about, and works in technology. So Kitty is going to talk to us about building a fashion tech brand. On that note, I'm going to turn it over to people who actually know what they're doing online and start to lurk again. So thank you both.
Thank you so much. Thank you so much, Nandini. I am going to be moderating this stream. So if anybody has any questions or comments, please do put them in the chat, or you can at me on Twitter. I recently just tweeted about this. I'll be monitoring that Twitter thread for your questions and comments, and also the YouTube. So basically, when a YouTube comment comes in, I can show it here. Let's take a look. Here we are. Already we've got one from Rebecca Broyle saying, hi there, it's been a great week. CETI is amazing. Thank you so much, Rebecca. And we've also got a comment already from Alana Rice, who's been hanging out with us quite a lot over the last couple of days. So thank you for keeping us company, Alana. And she says, thank you, Becky, for your contagious enthusiasm. So there's some love going on in between the CETI people there. So that's delightful. So anytime you've got a question or a comment, pop them in the chat. I will ask them all and show them all to Dr. Kitty Yeung at the end of Horror Talk, which I'm extremely looking forward to. So without further ado, I'm going to remove the two of us and hand you over to Kitty. Would you like me to add these slides to the stream now,
sure,
or would you like? Yeah. Okay, fine.
Yeah, let's do that.
Okay, great. Here we go.
All right. Hi, everyone. It's really nice to meet you here at CETI, and I'm really honored to be part of this speaker lineup. I've seen so many amazing makers and technologists presenting and showing their amazing work. So I'm really honored to be meeting you. So feel free to reach out to me if you have any further questions after the session. I'd love to be discussing around wearable tech, e-textile, and anything art and science combined. So for today, I will be giving you a short presentation about my experience building, first of all, wearable prototypes, but then later on scaled into production and building a wearable focused ready-to-wear company. A little bit about my background. I have a physics PhD. That's my still my day job doing hardcore science. Right now I'm at Microsoft quantum computing team and building the most cutting edge technologies that could help save the world. On the other hand, I really love art. I really enjoy making music and painting and fashion design. So it's in a way inspiration that I get, because if you think about science and art, they may seem to be really parallel tracks, but they really inspire each other. At least for my case, I always get inspired from nature, which itself is art. So by looking at how nature behaves and studying that through physics, it also allowed me to enjoy the beauty in our universe and nature, and understanding how the world works and how to build things to help more people. So as I'm working on hardware and quantum computing, physics, I am also exploring this artistic side. So I've been doing that for as long as I remember. Now you can see that I actually have some projects in Microsoft also working on fashion tech, but it's very different from the wearable tech I'm going to primarily show today. So I'll be giving you some examples where I've been focusing on, I try to make all of my projects a combination of science, engineering, design, and art. As I mentioned, to a lot of people, they seem to be separate fields, especially art and science seem to be the two extreme ends. But they are really similar. They are both exploring the unknowns and doing things no one had done before, and they then feed back to inspire practical fields like engineering and design. And it's where at the interface we build things that people need and people love. I'm giving you some examples of my early work. A lot of the hands-on, handmade prototypes that I use open source hardware to do. This is a machine learning dress that I arranged LEDs in the shapes of constellations. And this is Arduino 101, so it has pattern matching engine, Bluetooth, accelerometer, all embedded into the same board. And what I did here is programming the board to recognize my gesture and train it to memorize it. So then next time I wave my hand in the correct way, a corresponding constellation shows up. This is also a design using one of my graphic novel pages, a scientist and her robot looking into the telescope where there's the sky area, the constellations show up. So this was one of my really early early projects, and this was actually the very first one that I posted on open source platform and share with the community. That was really interesting experience. And now I also explore a lot of the applications, technology, functionality embedding into clothing. This is a heart rate monitor dress where you can see I have 3 points attached to my body, and you can see there's the computer screen here detecting my heart rate. And the blinking of the LED is synced to the heartbeat. Of course, not everyone wants to show their heart rate, heartbeats in the public, but this is to demonstrate that we don't have to constrain our imagination in just functionality in medical wear or sportswear. What about making something that's beautiful that I want to wear on special occasions, or something that I want to wear every day? I wanted to push the boundary of where we can add technology to something that's also aesthetically pleasing. I also explored detecting environmental data. So biometrics is one thing that we can do. We can also use environmental data to trigger functionality on clothing. This is a dress that uses a special material called from a company called Made of Mars. It is a volcanic rock that can be melted down into that can be melted down and then poured into fiber and then weave into fabrics. So it by itself is already quite interesting. But then I thought, why are we making things using these materials? It is to prepare us to go into a different environment, say Mars, because this kind of material can be found from volcanic areas like Iceland and Hawaii, but they're abundant on Mars. So this is for research purpose. A lot of the work has been done on producing all kinds of things using these materials, including fabrics. But fabrics right now, they are used in more harsh conditions for industrial application, like wrapping really hot pipes. But then I got this challenge from my friend from Made of Mars, who said, can you design something fashionable? So this is really future looking. Like if we migrate ever go to Mars, we need to build something using the raw material of that planet. Then I thought, so why do we even want to go to Mars? Do we need to go there? Is it because our own environment is being damaged on Earth, so we have to escape? So I embedded this optical depth sensor with the Adafruit Circuit Express playground that also has temperature sensing and buzzer and LEDs. So this dress detects the environmental data, the air quality and temperature. So it's a concept to warn people about global warming and air pollution. Of course, this is just a concept, but imagine if in the future we have to, each of us can wear something like this that detects our data of the environment and perhaps share the data through the cloud. And we each can be a sensor of our environment. And I also explored interesting applications of Bluetooth. This is through the Tiny Tile that also is an Arduino 101 typed board. So they have Bluetooth. You can program them to sync. And this is a pair of glasses that can change from transparent to opaque. So imagine you're wearing some sunglasses like this on the street, and then you see a stranger walking down the road wearing something similar. You think, oh, we have similar fashion sense. Maybe we can check each other out if our heart rate matches. So it's a really fun thing that if you can have this interaction between people, is human interaction assisted by technology rather than just human computing interaction. And this can provoke a lot of interesting, friendly interactions between people. Just like if you have that occasion, it's like physical Tinder. But also, if you had dogs would communicate, and the human owners would start communicate. So that's a similar type of idea. And then another play with the Bluetooth is these brooches that also connects through Bluetooth. Imagine a child wearing this with her or his mom, parents, and the pair is matched, and they can detect each other distance. If the child runs away, the mother's vibrates, and the mother, there's no connection needed with the phone or anything. The mother directly gets notified. and then the mom would start looking for the child. At the same time, the child's LED would stop blinking because they are separated from mom. So only when they get back to mom, it would then start to connect. So this will be a really, really cool thing for family and friendly interactions. So in fact, I work with DF Robot to scale this idea and made that into actual products, which I will show you in a little bit. So now you can see we have these PCBs in a flower shape, and they have exact functionality. But what's even better is that you can use these boards to learn programming. I got a lot of good feedback from parents that they are really inspired by this, using these flowers to inspire more girls, especially to go into STEM. So that's what I did when I started being a maker. That's already been 7 years, and I learned a lot of things through this process, and it actually has a lot of overlap with my experience in academia doing research. So if you are doing a PhD, you find yourself perhaps driving something really cutting edge, and you are building something no one has done before. You have to theoretically prove that works, and you run simulation, you may go to fabrication, a clean room to make your, so for my case, I designed chips, chip components, tiny nanometer and micrometer sized components, and went to the clean room to make them. And then of course you need to measure them to validate your design. If everything works out, or if it doesn't work out, you go back and repeat. And then you publish your results, and you're pushing the boundary of human knowledge, and you're contributing to the scientific community, and people would then develop on top of what you develop. In fact, doing wearable is very similar. I kind of unintentionally applied similar logic. So you start with the design. You saw in my case that I make a lot of things using fabrics, and I make e-textile using conductive threads and small components that can be sewn into clothing, into fabrics. So I need to select the right type of hardware for my particular application, and then program it to make sure everything works before I actually do the assembly. And of course, the very last step is like maybe teach or write it up as a tutorial. In general, is showing to the public, very much like publishing a paper. And now that since you've been going to the workshop, you understand how these are made, is really using these off-the-shelf components that are now designed for makers, and a lot of them are even designed specifically for wearables, which are really, really helpful. Like Adafruit's boards that has really large pins, then you can then sew conductive thread directly onto the boards, which are amazing. So I don't think 10 years ago we would be able to do anything like this. But with the growth of the open source community, and the hardware gets smaller and smaller, it becomes easier for us to create all kinds of interesting applications. There are, of course, still issues in terms of technology and hardware. Like battery is always a bummer. Is maybe you design something really slick and wonderful, but then you have to use a bulky battery. The conductive thread is still quite challenging to do, especially, I think at the prototyping stage, that's fine. We're building things by hand, but then scaling that to products is another issue. So there are a lot of inputs and outputs and connectivity that you can choose from. So vast variety of interesting. Once you know how it works, you can come up with all kinds of ideas, and you can just put all these different components, mix and match them, and build your imaginations into reality. So I went through this process of learning from the open source community, from the makers. Everyone's so friendly and helping, supporting each other. People make their projects open source. So I want to contribute back as well. So I make my projects also open source to educate more people, and hopefully helping people see how they can make something similar. So if you're interested, this is my Hackster.io portfolio. You can look up for a lot of the projects that I've done over the years. But not everyone is a maker, and I often get asked, where can we buy your things? That's the consumer mentality. They don't know that they can actually just buy the component and make for themselves. But then on the other hand, that there is a large challenge of educating the community, the larger audience, to understand where our technology is at. So sometimes you find that if you don't put a price on something, people just don't get it. So I had this experience several times when people asked me to scale my designs. So this was an example when I was still working at Intel. We had those open source hardware boards, and during Maker Faire, we would participate. We had big booths where volunteers would go and help out. I was asked to design something the volunteers can wear. Usually we wear a t-shirt, but we of course want to show off our products. Shouldn't we design something really cool to demonstrate it? So I made this design of a t-shirt that has a wearable robot that's using some LEDs and distance sensor and display. When a visitor approaches you, it detects the distance and it shows hello message and the product information on the screen. So it's a really fun interaction. But then on the shirt, I also made this soft circuit by hand. I hand sewn the conductor threads and the LEDs, and also magnets that can attach these robots onto. Would be super cool if we made that and everyone wore this. Just imagine the interaction that people will have. That would be a perfect way to apply these components and also demonstrate to people how things work. But then we couldn't find any manufacturers to do this. I had to handmade one, but it's not possible for me to make like 100 for all the volunteers. The hardware, the robot was super easy to do. You can find any hardware manufacturer to do it. That's not a problem. But the soft part was the difficult part. We couldn't find any manufacturer that's able to put conductive traces, designer-defined traces onto a piece of fabric. We were looking for embroiderers, but they were just too traditional. They didn't know how to handle conductive thread at all. And they freak out when you try to say, maybe try using this conductive thread and thread it into your embroidery needle. They didn't have it back then. And there's another way is to put conductive ink. You draw using conductive ink onto the fabric. But back then, that wasn't really available. There were companies doing that, but they couldn't guarantee a certain amount of washes. So this project didn't end up happening. It was really sad. But then it really triggered my curiosity. I could just stop there and say, okay, I don't know where the industry is not there yet. I can do things by hand myself. But then I was just too curious. I wanted to push. I wanted to figure out how things works. How can I, as an independent designer, make something that I can do by hand, but make it repeatable? So we actually have a problem in wearable tech. I wonder, since this is interactive, people can comment here. Where do you think we are in terms of technology adoption for wearable tech? So this is the technology adoption cycle. If you are in the startup world, you may know this curve very well. The one on the bottom shows you that there's only a small percentage of people that are innovators. So we see things that are new. We think about how we can push the boundary and make something that no other people have done. So these are the innovators, and I think in the audience, we're all innovators if we are really in the wearable space. And then there's a small early adopter, small percentage that would see the value of it and they think, oh, I'm enlightened. I see this will be very valuable, and then they would buy your idea. Sometimes it's your immediate circle. But then there's an early majority that's a large part is a hurdle, and they call it a chasm in between, where sometimes a lot of new ideas just fail there. There's a little cartoon that I posted here that basically tells you how to interpret this graph. And also imagine anything that has been through this curve. So smartphone is one of the examples for a developed place. Everybody has a smartphone now, and the laggards are the ones that just resisted it. I don't want any new things until this thing goes out of until the old phone goes out of market. Then they would only adopt by then. If I can see the comments, if anyone commented where you think. Yeah, so Rebecca says we're in the early adopter stage. Yeah, that's right. And I think we are actually, the wearable tech is in the chasm for years, for actually a lot of years. We heard wearables in the news, in industry was a buzzword a few years ago. And then people found out there's actually a hurdle. Actually, there's a large technical hurdle. I think this hurdle has to be overcome only when there's technical solutions. There are ways that we can push this forward. And this is what I think the main things that I learned in industry is about scaling. So it's not always the most interesting part. Most fun part, I think, doing research, doing prototyping. When you have an idea, you can immediately go do it by yourself. That's super fun. And in a way, it is a easier side of things. If people can be satisfied there, people can just stop there and just repeat from like what I had shown from theory to development and publishing, theory, development, publishing, also in terms of wearable, design, build it, show it, design, build it, show it. Just go through the cycle and be happy with it. But then if you are curious and just want to see what's outside of it, there are a lot of annoying things. You have to figure out the market. You have to get the funding. You need to convince people that it is valuable to do. You have to have a business model and work on the scalability. I mentioned there's a hurdle because there's actually a technical hurdle in wearable tech. Yes, we can get those components, but the industry is not ready to scale it yet. There is a small industry, relatively speaking, working on this for sure. And then everyone's asking, what is next big app? They're like, what is the killer app? Then that is actually a question that stopped people from innovating. It's like, where can I make the most money? If I don't see that, I'm not going to invest in there. And that really hurts the maker mentality. So I think this is definitely, in a way, interesting, but also to a lot of intellectually driven makers is also the annoying part. But I think there is still value to push, and I will show you that. I was just too curious, so I got into this rabbit hole. I started building a fashion brand specifically focusing on wearable tech and how to make it ready to wear and repeatable. And when it comes to manufacturing, you're really constantly battling against limitations. It's not always that you can make some prototype by hand that can be produced. It comes from the gaps between these three areas. From research, yes, there are a lot of research studies to make the next flexible battery, or the next thinnest LED wire. You can weave it into fabric, something like that. But it takes years to scale it into industry scalable solution. But then the industry may not want to invest in it before they see where is the application, where can I make money. If they don't immediately see it, they don't want to invest to push the technology forward. And then even if we have some industry solutions, it doesn't mean that the public and the creative community can get their hands on it. Things that there are printed electronics, there are really fine miniature electronics in industry. But if they don't get in the hands of creative people, then there's not something that not enough people is building things that people want. We need creativity. We need technologists to get their hands on these technologies and build something that appeal to more people, that people see that they actually want them. So there are there are these boundaries that I'm trying to push through all these processes. So building a fashion brand means we need to develop ready to wear. We need to push through the chasm. There are these several things. Develop ready to wears. So it's not just demos or coutures that are very, very expensive and people can't afford. Make things that people can afford and make things that make sense. It's not making technology for the sake of technology, but build things that make sense, that people would like, and also develop off-the-shelf components. As I mentioned, industry is not doing this enough. We need to provide creatives with options that they can use. The most cutting-edge solutions out there, they're not off the shelf. You have to know someone. You have to have I've seen over and over in big companies, in their most cutting-edge labs, they have already solved the problems of putting, say, make e-textiles, putting touchable sensor or tiny LEDs embedded into fabrics. They exist, but they are lying there on the desk of a lab where their main products are not sure whether or not to adopt that technology. What if they can put these things off the shelf and get the creative people to take the lead and have maybe consumers to say what they want? And we need to develop scalable processes. As I mentioned, not everything that we can do by hand right now can be reproduced. And another thing that I noticed is customization. If we are making wearables, we need to just think about fashion. Everyone has their own ideas of what they want to wear. They want to have different, maybe they like the shirt I'm wearing, but they want to change the length on my sleeve. So think about technology in the same way, that maybe someone wants this particular dress, but they want this kind of functionality in it. So can allow people to modularize and mix and match. So if we do all of these things, we can gradually push the industry forward. So very recently, my brand just finished a successful Kickstarter where we did develop new solutions and new designs that are scalable finally. So this is some examples, like putting LED arranged in constellation. You see the theme here. I was only building those things by hand, and those are just demos. But now they are ready to wear. These circuits are printed onto fabrics. You can put really fine LEDs on the fabric and embed it into shirts. And that's my constellation shirt. So it makes sense to have your birthday constellation in the shirt. On the right here is a dress that displays whatever gifts or videos or images that you draw. So on here, I'm actually, if we have time, I can show you the dress on the screen, where you can program it. You can upload any images from your phone to display, and it's an earth dress, so it matched perfectly. And then that's using off-the-shelf component. And then we also developed specific e-textiles. Like the one on the left is a collaboration I did with a German company that makes solar panels in an artistic shape. You might have seen solar panels just in a regular geometrical shape, but we're able to make them really beautiful. This is lotus that match with two of my designs very well. So we laminated them onto the fabrics, and we can charge any electronic devices on the go. On the right here is a dress that is already reversible. So they have my paintings on. So all of the designs on my paintings on the fabrics. I was so inspired by perennials in my garden last year. So I drew on both sides of the coat. And then you can just put on a battery and heat it up. That's using, you may know Lumia Tech. They have these off-the-shelf components, flexible circuits you can buy and just apply to your design. It's really convenient. And then I mentioned earlier these brooches that we developed from my handmade prototype to actual PCBs that's scalable. So if anyone backed our Kickstarter earlier, thank you so much. I have to really appreciate everyone's support here. So these are the some of the directions that I am pushing for this industry to go to the next stage. But also, while I was doing these wearable tech, I also found a lot of problems in the fashion industry itself. So that is a topic for another talk, I think. But I found that we have to support independent designers when they have a good idea. We need to have a way for them, affordable way for them to make it and display it to a bigger audience. And only because right now the fashion industry is so driven by mass production, the manufacturer, they don't want to make anything until they see there's a market. But then the public don't know what they want until they see something existing. And then that doesn't generate the market promise that the manufacturer want. So that's an ongoing negative cycle in the industry. So I'm actually developing a platform at Microsoft, is connecting a complete ecosystem that can allow designers to bring their ideas into reality much faster. Right now, I can share with you that my brand, just to develop a new set of designs, it takes 9 months to a year. Where when I have a design, I can have an idea, I think about it in the morning, and I have the prototype done in the evening. But then to make it into a product took months and months and months, even without technology embedded. Just the clothing themselves is such a long process. Coming from an engineering background, I don't think that makes any sense. We can use technology to support designers to get their vision into reality much faster. So I'm building this platform to support. So if you are interested in this, we can discuss more. And then here I also highlight at the bottom is we have to have a platform like that and have the components be part of the manufacturing process and have ways to scale the electronics, the technology in order to do that. So I don't think our wearable tech can be the mainstream until we have a technology platform built for just normal clothing. And then we can gradually add in these electronics as components where manufacturers know how to handle. Right now, the fashion industry don't know anything about making electronics, and the electronics industry don't know anything about making beautiful fashion. So I think we need a complete ecosystem, and we are a long journey ahead. At the same time, while we build these technologies and while we still are pushing the boundary, we can also do something more positive to the environment. Because another thing that I found about building a fashion brand is how not just the time, but how costly it is and how wasteful the whole industry is. For my small brand, that's so much easier to control. I can make things made to order. But because the industry is dominated by mass production, things get overproduced, and 30% of clothes made in the entire world gets sent to landfill or burned every year, and it generates 10% of carbon footprint. I can talk people's ears off about all these numbers and how polluting our current fashion industry is. And I think if my brand scales, it cannot do it the same way. It has to do made to order, but also donate to environmental protection, and also donate to where the inspiration comes from. In my examples, you see all my designs are inspired by nature and science. So the profit that's made through building this brand is donated to the STEAM and environmental protection. So I think my small brand does this, and bigger brands should do that too. We shouldn't be making on the cost of polluting our environment. So that's pretty much the summary here. By doing all these explorations, I connected a lot of dots and got inspired from nature and science to apply into art, but also get inspired from art to apply into scientific and technological work. In a way, a lot of problems in our industry is caused by the silos and people in different industries not understanding each other. But if you look at things as a whole, we are making technology to empower people to do things maybe more efficiently, so that you can be relieved to do more artistic work, more enjoyable work. Why do we need that? Because that's where happiness comes from, and that keeps our society going forward in a positive direction. That is the conclusion of my talk. Thank you, everyone. I see very active in the chat. So thank you very much for listening.
Thank you so much, Kitty. I'm going to bring in Nandini as well, because I know she's got some questions. But before we ask our questions, I just wanted to highlight a couple of things from the chat here. It's been popping off. People are saying lots of really amazing things about your work, saying about the environmental. Alana said she needed one of your projects when her kids was little. And Rebecca said, I need the blue note for my dog. We've got, so you're sharing knowledge, people sharing knowledge of materials with you. And then, yeah, absolutely. We all agree that you're a trailblazer. And Selena makes an interesting point, saying that cosplay becoming such a huge thing is really helping with the adopting of wearable tech. Is that something that you'd agree with?
Mm-hmm. Yeah, I totally agree. It's also very edgy community. And I see a lot of amazing cosplayers and special effects that's only achievable in anime. You have to use technology to achieve. Yes. But it's still small. It's not even an industry. It's a community. So it's a niche audience.
It's true. And there's a lot of chatter about your solar panels as well, including Selena again saying the off-the-shelf charging panels that you can sew on your clothes. Is this something that you've arranged with this manufacturer yourself, or is that something that mere mortals like us could also have access to in the future?
Yeah, very good question. I really want to push it to be something off the shelf, but of course, at this stage, basically is two companies collaborating.
Yeah.
And what I found is I show the gaps between the three, the research industry and the public. I've been given talks in a lot of conferences that are basic companies like that they make components, even also these ones, conductive ink, but then they're not making them off the shelf. So
maybe in the future.
Yeah, I really want to push that to open it up for more creative. Usually is a mindset that the industry has to want to produce product and then sell the product and make it mass produced. But then, as I showed, that's actually has to change.
Yeah. And another question about the solar panel, again from Celine. Oh no, that's a different one. That's true. Batteries that go through the wash would be very handy, but I like the solar panel. So Rebecca asks, is the solar panels how are they actually attached? Are they woven in, printed on? Are you attaching them yourself afterwards?
Is laminated.
Oh, so talk us through how that happens.
So the company actually handles the process. I don't have to do that myself.
Wow, that's so interesting.
But they developed this process to laminate it onto all kinds of fabrics. It's really, really nice. And they have all kinds of designs too. But what I really love about them is that they are very open on developing artistic designs like this. And it's not like I think a lot of these companies that I make relationship with are very open to the creative ideas, and they want to support creative technologists. And one thing that I really want to suggest, and I've already suggested, but have these companies think about it, is maybe have a way for creative designers to submit their graphics and make solar panel in that shape.
That would be so cool. Imagine if it's like Oshcut, right? So for those of you who don't know, I've only recently discovered this, but Oshcut is like a service where you can send off your designs and get them back cut out of metal. So like a large piece of metal. Yeah, so Sophie Kravitz has been doing that for a project, and I was like, what? Yeah. And then I saw this, I was like, what? Would it be possible to do such a thing with solar? That would be so cool.
That is. And all kinds of other, like defining the electronic traces on fabric. If you allow creative designers to do that, and you can just print it out. But that means one off. That's one at a time. So usually they don't know how that works yet. It's risky. Maybe more costly to do things one off.
Well, huge admiration for all of that, and not just one of these things in your Kickstarter, but it's like normally one person like, okay, I'm doing a solar panel dress, that's my Kickstarter, but no, that was just one of the many rewards that you put in your Kickstarter, along with the Bluetooth brooch, which was the one that I backed. Of course. And it was just so impressive to see the range of things that you're working on, and everybody here in the chat is agreeing. Here we are. Thank you. Great talk. Someone on Twitter saying how much they love your dress as well. It's so good.
You can check that on my website too. Just my name, kittyyeung.com.
Yeah. So Nandini, did you have any questions that you wanted to pose?
Sure. I'll ask something that's a little more sort of a little off topic, a little related, a little more high level. But I was curious. You've talked a lot about the role that creativity can play in sort of these designs, in even technology and manufacturing, and the role that and you talked about sort of supporting STEAM, and I'm curious if you think whether you've thought about ways where we could encourage artists and designers and give them permission and space and access to experiment more with technology, with engineers in that R&D phase, not just as separate, and same way sort of work with engineers to give them permission and access to be more creative, to make things that are one-off or beautiful or useful rather than just mass-produced. And I'm curious your thoughts on that.
Yeah, a lot. That's why I have this project at Microsoft, is to support creative designers to be able to use technology and make their clothing on demand. And they definitely need engineers' help. And the engineers also get inspired when they build something like this. Sometimes we may think that engineers don't care about fashion very much, and they're from the technical field. But that's actually the problem. The fashion industry and the technology industry are developing very, very separately. They hardly talk to each other for so long. And the problems that exist in the fashion industry are not well understood in engineering. So you may think people in engineering are not interested in it, but then when I started telling my colleagues about problems in fashion, the light bulbs just light up. Oh, that's something we can help solve. It's like our skills. We can build technologies to support them. I see Selena posted is a great question. Selena knows about Spoonflower. Spoonflower is actually the fabric printer of all my designs. I do all the digital painting. I'll do all the painting digitally on my computer, so it can be scaled really large and printed onto anything. Spoonflower is a website you can upload your images and choose the repeat design and choose the fabrics, and it ships to you on demand. And I think this model should be applied to all kinds of physical products. And if they could put conductive ink on it, that would be amazing. But I don't know if they have any intersection with the maker, the electronic maker community. I definitely want them to have this idea. I've also asked people who do conductive ink to do something like what Spoonflower does. Mm-hmm. That is still very new. It's new, so. I think there's a lot to learn from each other. I think the burden here is always that people need money. People need to have the funding to do something risky. And you need people who, you need source of income.
Speaking of which,
how
can people support you? So Selena's asked if your designs are open on Spoonflower for purchase, and how would people find that?
So thank you. So you can find all of my designs on the ready to wears on kittyyeung.com.
Let me just spotlight this so you can see. So this is how to get in touch with Kitty. There's the social media handles there, and then there's the designs and the things that you can purchase on kittyyeung.com there. And what's this art by physicist Kitty? Is that more like a portfolio website?
Yeah, that's my personal. It's got everything. It's like my scientific research, my painting, my music. But the kittyyeung.com is the fashion brand. And I actually make a lot of the easier to sew patterns open source. So
nice.
I really want to make fashion also open source. So I'm starting to do that.
Yes.
So I paint the fabrics, the painting on the fabrics as well as the patterns. So you don't have to get any paper pattern. It's all these transfer error and really tedious process. You just get the fabric with the patterns on it, and you can directly cut the fabric. So through those pages, you can also find links to Spoonflower. If you just want the print without the pattern, they're also available.
Very cool. Thank you for sharing that. I love the idea of making fashion open source as well. And what kind this is, I think there's lots of different industries and lots of different kind of research areas that are kind of becoming more and more aware of the benefits of opening up their research and opening up their designs. And it's really good to hear that there's people thinking about that in terms of fashion as well. What kind of thing do you think open source would bring to fashion? Like how would you envisage this? Because you're a person who's always got very big, grand visions and ideas. And it's really interesting to hear your ideas on how an industry is developing.
Yeah, several things open source can help solve, especially on the pollution and waste side, where we need ways to do made to order. We need to be able to not make things overproduce. We need to only make things when people want it. So open source, in one way, is allowing democratization of manufacturing. People like us who have the skills to sew, if we can open source the designs, it doesn't mean it's free. You still own the intellectual property. And if you're a designer who maybe sell your patterns or share it with the platform, if anyone buys your design, you still get paid. So it also get rid of the copycat problem, severe in fashion. So if you have the skill to sew yourself, you can build your own brand and you can make things for other people. The other thing is open source can help people realize what's possible. So I'm trying to use the open source like Hackster.io, Hackaday.io. These are open source platforms inspiring the technical engineering communities. What if the fashion industry also start to look into this, and they or even consumers start finding things on here, and they understand what's possible, and they get inspired. Maybe they get turned into a maker, or if they like something, they can purchase from the creators. So I think we need to. I think the trend, there's no trend in fashion in the future. Everyone has their own ideas. Everyone wants something unique. And open source can also allow modularization. So people can say, I want this kind of length, I want this color, this kind of prints. We can make them customizable. So all in all, I think the bigger problem is solved is the pollution and industry impact, where I gave some numbers, and then number one reason people return something is the fit. Also the fit. They buy something online, they try it on, it doesn't fit, they return it. It also generates a lot of waste. So I really think we need to get rid of inventory and only make things when people want it.
To order. I love that vision of the future where it's almost kind of reminiscent of, like, I don't know if you watched the movie Clueless. So she's got a wardrobe and she can like scan through and figure what she wants and what matches and that kind of thing. And it kind of reminds me of that. And I love this idea of a future where I can just dress according to my own whims and have things delivered to me that specifically fit my body. To my taste, that is considerably less waste and also way more unique because we've chosen it ourselves. I love that vision of a future, replacing fast fashion with couture for the masses, essentially.
Exactly. Mass innovation. Yes.
Couture for the masses, interactive couture for the masses.
That's right.
Right. That's what we want. We love it. We love it.
Yeah. Well, I'm going to step in on that note because that was a beautiful summary of everything. This has been an incredibly inspiring talk, Kitty, and a conversation, Kitty and Helen. You've sort of brought it all together in this beautiful way. And it's a beautiful end to our workshop and speaker series. It's not the end. If you want to continue the conversation, join the Discord, continue on social media, share these talks and watch them again and again. We're going to do a lot more things, especially related to wearables and maybe an institute and a more advanced building to something more advanced next year. So join us if this is something exciting to you, and our experiments and how to bring sort of art, technology, innovation, manufacturing, research all together to in a collaborative way. So thank you all very, very much.
Thank you, everybody. Thank you. And I'll see you again soon. All right. Bye.
Bye. Thank you, everyone.